All right, today we're cracking open an absolute classic, a book that has probably launched more programming careers than any other. Let us see. We're going to dive into why this language, which, is decades old, isn't some dusty relic. It's actually one of the most powerful and relevant tools a programmer can have in their toolkit, even today.
So let me ask you something. What do you think is the invisible force powering your operating system? Or the tiny brain inside your smart camera? How about the engine control unit in your car?
Well, the answer might surprise you. It's this. Just a single letter. C. Yep, a programming language that's been around forever, but it is still, to this day, the absolute bedrock of our modern digital world.
Okay, so first up, let's explore just how massive C's footprint really is. It's kind of everywhere.
You'll find C is basically king in three major areas. First, operating systems. We're talking huge parts of Windows, Unix, and Linux. Then you've got device drivers, those crucial little programs that let your computer talk to, say, a new printer. And finally, embedded systems. That's the smart stuff in your microwave, your phone, pretty much everything. So why? Why C in these places? It all comes down to one thing: raw, unadulterated performance and speed. For these critical jobs, that speed isn't just a nice to have, it's absolutely essential.
Okay, so how does C pull this off? How does it get that power? Well, it's all about its programmer's toolkit. It's simple, but man, is it effective. Let's take a look at the core pieces. First things first, we've got what are called keywords. Think of these as the fundamental, built-in commands of the language. They're like the verbs of C. They tell the computer exactly what to do, and they're reserved, which just means you can't go using them as names for your own stuff. So take a guess. How many of these core commands do you think C has? 100? 500? Nope, just 32. That's it. The entire vocabulary of the language is built on this tiny, tiny set. And that's not a weakness. It's actually its greatest strength. It's just a testament to how elegant and powerful this language really is. All right, next up, expressions. So if keywords are the verbs, you can think of expressions as the full sentences that actually perform calculations. It's just like in your old math class, right? They combine numbers, variables, and operators, plus, minus, that kind of thing, to get a result. And what's cool is that moving from algebra to C is super intuitive. Look at this. Standard formulas from math class translate almost one-to-one. The only real difference is you have to be really explicit and put in a little asterisk for multiplication. But the logic? It's exactly the same.
But just doing calculations isn't enough to make a program smart. The real magic happens when programs can make decisions. That's where the intelligence comes from, the ability to react when things change. And I just love this quote from the book. It really nails it. We all need to alter our actions in the face of changing circumstances. That's what programming is all about. A program, just like a person, has to look at a situation and decide, okay, do I go left or do I go right? So how does C do this? It uses these little tools called relational operators. They're just symbols that let the program compare two things. Is this number bigger than that one? Are these two names the same? And the answer, which is always just a simple true or false, decides what the program does next. Okay, and listen up, because this is the classic mistake every single new C programmer makes. A single equal sign means you're assigning a value. It's like saying, hey, computer, from now on, x is 10. But a double equal sign, that's a question. It's asking, hey, is x already equal to 10? Mixing these two up, oh man, it will cause you some serious headaches and some really weird bugs. Let's see this in action with a super simple if-else structure. So the program checks a condition, right? It asks, did the customer buy more than 1,000 of these things? If the answer is yes, it runs one piece of code, in this case, applying a discount. But if the answer is no, it runs a totally different piece of code. It's just a fork in the road, but this simple idea is the fundamental building block of literally all complex software. All right, so we've seen the basic nuts and bolts. Now, let's zoom back out and talk about why these simple ideas make C a language with such an incredible, enduring legacy. Really, C's superpower is that it's so direct. It doesn't hide the machine from you behind a bunch of complicated layers. It lets you get right down to the metal, to interact closely with the computer's hardware, to manage memory yourself. And it does all of this without sacrificing one bit of speed. So if you boil it all down, C is still so important for 4 big reasons. Number 1, its unmatched performance. When you absolutely need speed, nothing else comes close. Number 2, memory control. This is crucial for all those little embedded devices that don't have a ton of memory to spare. Number 3, portability. You can write a C program and, with a little work, get it to run on almost any computer out there. And maybe the most important reason of all, C is foundational. When you learn C, you're not just learning a language, you're learning how computers actually work at a deep level. And that makes you a better programmer no matter what language you end up using.
Look, at the end of the day, C isn't just another programming language. It's a direct line to the hardware. It literally hands you the keys to the machine and says, okay, you're in charge now. So the real question isn't just about what C can build, it's what are you going to build with that power? Thanks for joining this explainer.